So the median, which divides a distribution in two at its midpoint, is the most well-known example of a quantile. So using our distribution x, yet again, the one that has this skewed distribution and that we created here in the preceding video, that distribution has a median value of about 0.7. And that corresponds exactly to the quantile at 0.5. So what we do with this quantile method in NumPy is we pass in our vector of values, in this case x, and we indicate where we would like to split that distribution. So we can put in a value here from 0 up to 1, and so 0.5 gives us the midpoint, which is exactly the same as the median. So we get exactly the same value here. Generally speaking, beyond just the median, quantiles divide up distributions, and the most common are percentiles, quartiles, and deciles. We're going to cover all three in turn now. So percentiles first. They divide the distribution at any point out of 100. Pourcent is French for out of 100. For example, if we'd like to identify the threshold for the top 5% of a distribution, we'd cut it at the 95th percentile. Or for the top 1% of a distribution, we'd cut it at the 99th percentile. All right, so continuing on again with our skewed distribution that we've captured in this vector x, we can ask the NumPy percentile method to provide us with that dividing point, to divide the distribution and give us where the 95th percentile is, or the 99th percentile. So you can pass in a single value or a list of values, and so we can find out that the 95th percentile for this distribution is 2.06, and the 99th percentile is 2.52. And to make sense of that, let's plot out these actual values. So I've captured them in this vector p, which just has two elements for the 95th and 99th percentile respectively. So we can replot our distribution of x, and so it has that median of around here of 0.7, right? So the median is about here, and we plotted that earlier. The 95th percentile occurs here, and the 99th percentile occurs here at 2.06 and 2.52 respectively. Note that the NumPy quantile method, which we used earlier here, gives you identical results to the percentile method, except that we pass in proportions ranging from 0 to 1 into the quantile method, whereas into the percentile method, we pass in values ranging from 0 to 100. So we can get the exact same results as we did with the percentile method with the quantile method if we pass in a list of, so here's the 95th percentile as 0.95 out of 1, right? And same thing, 99th percentile, but now kind of out of 1 is 0.99. So we get the same values, but we just need to, instead of having them out of 100, like we do with the percentile method, we put them as out of 1 for the quantile method. All right, so that covers percentiles. Let's now talk about quartiles. So as their name suggests, quartiles are quantities that divide a distribution into quarters by splitting the distribution at the 25th percentile, the median, also known as the 50th percentile, and the 75th percentile. So 25, 50, 75, those are the quartiles. Let's have a look at them. So in order to get the quartiles, we can use the percentile method and pass in a list at the 25th, 50th, and 75th percentiles to split at those points. Or as we just discussed, you could use the quantile method instead and pass in 0.25, 0.5, and 0.75. Either way, you'll get the exact same split points in the distribution. So let's plot those out. So we get our median here again shown in green. We've already plotted this earlier in this notebook on the distribution. And now we also see where the 25th percentile lies, and we see where the 75th percentile lies. So these three values are our quartiles, dividing the entire distribution into the bottom quarter, the second quarter, the third quarter, and the top quarter here. Okay, and having covered percentiles and quartiles, let's now talk about deciles. So that word comes from the Latin decimus, meaning tenth. And a fun fact there, so the verb decimate comes from the idea that your army or your unit or whatever is attacked. When it's decimated, a tenth of the people are killed. Anyway, so a decile divides a distribution into 10 evenly sized segments. So to see that in our hands-on code demo here, I'm using this list comprehension here to show that this range method call that I have here is giving us 10 values from 10 up to 90. I'm using this list comprehension here to show us that this range method call gives us 9 values ranging from 10 up to 90, and those 9 values are the 9 percentiles that we would like to split our distribution of interest at in order to get the percentile thresholds. So these 9 values divide our distribution x into 10 evenly sized segments. Let's plot them out. Here they are. So the bottom tenth of values fall in here, the second tenth is here, the third tenth, and so on. And so we can call those deciles. So the bottom decile, the second decile, the third decile, all the way through to the top decile, the top tenth here. All right, so all of those various quantiles, the percentiles, the quartiles, the deciles, they give us so many different ways of slicing and dicing our data. Wouldn't it be nice if we had a plot where we could kind of see what our whole distribution is like at a glance? Well, I've got the box and whisker plot for you up next to do that.